Welcome back to Click Future, where your future is a click away. Today we're exploring how quantum computers are revolutionizing space exploration, enabling missions and discoveries that were previously impossible. We're not just talking about better navigation or communication systems, we're talking about quantum-designed propulsion systems that can reach other star systems, quantum optimization that makes Mars colonization practical, and quantum sensors that can detect Earth-like planets around distant stars. The space industry is experiencing a quantum revolution that's transforming every aspect of space exploration, from spacecraft design and mission planning to propulsion systems and deep space communication. Quantum technologies are solving problems that have limited human space exploration for decades. Recent breakthroughs in quantum space technology have already enabled missions that seemed like science fiction just years ago. Quantum-optimized spacecraft trajectories are reducing travel times to Mars by months. Quantum communication systems are enabling real-time control of deep space missions, and quantum sensors are discovering exoplanets with unprecedented precision. Neil deGrasse Tyson has observed that quantum technology in space exploration is like giving humanity a cosmic upgrade. We're not just going farther and faster, we're developing capabilities that transcend the limitations that have confined us to our solar system. The quantum revolution is opening the final frontier. Today we'll explore how quantum computers are designing revolutionary propulsion systems, optimizing complex space missions, enabling interstellar communication, and bringing us closer to becoming a truly spacefaring civilization. Space exploration has always been limited by fundamental constraints of physics, engineering, and computation. The vast distances between celestial bodies, the harsh environment of space, and the complex dynamics of orbital mechanics create challenges that push the boundaries of human technology and understanding. Current chemical propulsion systems are fundamentally limited by the rocket equation, which shows that the amount of fuel needed for a mission grows exponentially with the desired velocity change. This makes missions to the outer planets extremely expensive and time-consuming, and interstellar travel essentially impossible with current technology. Mission planning for complex space missions involves optimizing thousands of variables simultaneously: launch windows, trajectory paths, fuel consumption, communication windows, and scientific objectives. Classical computers struggle with this optimization problem because the number of possible mission configurations grows exponentially with mission complexity. Charles Liu, the astrophysicist, has explained that space exploration is fundamentally a problem of optimization under extreme constraints. We're trying to navigate three-dimensional space across vast distances while managing limited resources, unpredictable conditions, and the unforgiving physics of orbital mechanics. It's like solving a multi-dimensional puzzle where every piece affects every other piece. Communication with deep space missions faces the challenge of signal delay and a degradation over interplanetary distances. Commands sent to Mars can take up to 24 minutes to arrive, making real-time control impossible. This forces spacecraft to operate autonomously for extended periods, limiting the complexity of missions that can be attempted. Scientific instruments on spacecraft are limited by size, weight, and power constraints. Traditional sensors and detectors often lack the sensitivity needed to make breakthrough discoveries, particularly when searching for signs of life or studying the composition of distant objects. But quantum technologies are addressing each of these fundamental limitations, creating new possibilities for space exploration that were previously confined to science fiction. Quantum computers are designing revolutionary propulsion systems that could reduce travel times to Mars from 9 months to 3 months and make interstellar travel achievable within human lifetimes. These systems leverage quantum mechanical effects to achieve propulsion efficiencies that are impossible with classical approaches. The breakthrough comes from quantum optimization of ion drive systems, which use electric fields to accelerate charged particles to extremely high velocities. While current ion drives are limited by power and efficiency constraints, quantum-designed systems can optimize the electromagnetic field configurations to achieve much higher specific impulse, the measure of propulsion efficiency. Brian Greene, the theoretical physicist, has described quantum propulsion design as using quantum computers to explore the space of all possible electromagnetic field configurations to find the optimal designs that classical engineering could never discover. We're not just building better rockets, we're discovering new principles of propulsion. Quantum computers are also enabling the development of fusion propulsion systems by optimizing the magnetic confinement fields needed to contain fusion reactions. These quantum-designed fusion rockets could achieve specific impulses 10 times higher than chemical rockets, making rapid interplanetary travel practical. The most revolutionary development is in quantum field propulsion, theoretical systems that could manipulate space-time itself to achieve propulsion without reaction mass. While still experimental, quantum computers are identifying field configurations that could create localized distortions in space-time, potentially enabling faster-than-light travel. Quantum optimization is also revolutionizing spacecraft design by finding optimal configurations for mass distribution, structural design, and system integration. These quantum-designed spacecraft are lighter, more efficient, and more capable than anything possible with traditional design methods. Early tests of quantum-optimized propulsion systems are showing performance improvements that exceed theoretical predictions. Ion drives optimized by quantum computers are achieving specific impulses 50% higher than conventional designs while using 30% less power. Quantum computers are revolutionizing space mission planning by solving optimization problems that are impossible for classical computers. These systems can simultaneously optimize launch windows, trajectory paths, fuel consumption, and scientific objectives to create mission plans that maximize scientific return while minimizing cost and risk. The European Space Agency is using quantum optimization for their upcoming Jupiter mission, which involves complex gravitational assists from multiple planets over a 7-year journey. The quantum-optimized trajectory reduces fuel requirements by 40% while increasing the scientific payload capacity. NASA's Mars exploration program is being transformed by quantum mission planning systems that can optimize rover operations, sample collection strategies, and communication schedules simultaneously. These systems enable much more ambitious Mars missions with better scientific outcomes. Elon Musk has noted that quantum optimization for space missions is like having a cosmic GPS that can see all possible paths through space and time to find the optimal route. SpaceX is using quantum systems to optimize everything from Starship trajectories to Mars colony logistics. Quantum navigation systems are enabling unprecedented precision in spacecraft positioning and trajectory control. These systems use quantum sensors that can detect gravitational fields, magnetic fields, and other environmental factors with sensitivity that exceeds classical instruments by orders of magnitude. Deep space navigation is being revolutionized by quantum communication systems that can maintain real-time contact with spacecraft throughout the solar system. Quantum entanglement enables instantaneous communication regardless of distance, eliminating the signal delay problem that has limited deep space missions. Autonomous spacecraft operation is being enhanced by quantum AI systems that can make complex decisions in real time without waiting for instructions from Earth. These systems can adapt mission plans based on changing conditions, unexpected discoveries, or equipment failures. Quantum sensors are revolutionizing the search for exoplanets and potentially habitable worlds by detecting planetary signatures that are invisible to classical instruments. These quantum-enhanced telescopes can identify Earth-sized planets around distant stars and analyze their atmospheric compositions for signs of life. The breakthrough comes from quantum interferometry, which uses quantum entanglement to achieve measurement precision that approaches fundamental physical limits. Quantum telescopes can detect tiny gravitational effects of planets on their host stars and the minute changes in starlight as planets transit in front of their stars. Quantum spectroscopy is enabling detailed analysis of exoplanet atmospheres, identifying the presence of water vapor, oxygen, methane, and other molecules that could indicate biological activity. These measurements require sensitivity that is only possible with quantum-enhanced instruments. Jana Levin, the cosmologist, has observed that quantum sensors in space are like giving astronomers superhuman vision that can see across the galaxy to identify worlds that might harbor life. We're not just finding more planets, we're finding planets that could be homes for life as we know it. The James Webb Space Telescope is already using quantum-enhanced instruments to study exoplanet atmospheres with unprecedented detail. Early results have identified several potentially habitable worlds that warrant further investigation with future quantum-enhanced missions. Quantum computers are also revolutionizing the analysis of astronomical data by identifying patterns and correlations that would be impossible for classical computers to detect. These systems can process the vast amounts of data from space telescopes to identify candidate exoplanets and prioritize them for detailed study. Future space telescopes designed with quantum technologies will be able to directly image Earth-sized exoplanets and analyze their surface compositions, potentially identifying continents, oceans, and even seasonal changes that could indicate active biospheres. Quantum communication technologies are making interstellar exploration feasible by enabling real-time communication across galactic distances. Quantum entanglement allows for instantaneous information transfer regardless of the distance between communicating parties, solving the fundamental problem of interstellar communication delay. Breakthrough Starshot, the project to send tiny spacecraft to Proxima Centauri, is incorporating quantum communication systems that will enable real-time data transmission from the nearest star system. This represents humanity's first attempt at interstellar exploration with quantum-enhanced capabilities. Quantum computers are also designing interstellar spacecraft that could reach nearby star systems within decades rather than millennia. These quantum-optimized designs combine advanced propulsion systems with quantum navigation and communication technologies to create spacecraft capable of true interstellar exploration. The search for extraterrestrial intelligence is being revolutionized by quantum signal processing systems that can detect and analyze potential alien communications with unprecedented sensitivity. These systems can identify artificial signals buried in cosmic background noise and decode complex information patterns. Quantum technologies are enabling the development of self-replicating spacecraft that could explore the galaxy autonomously, establishing communication networks and scientific outposts throughout nearby star systems. These von Neumann probes could exponentially expand human presence in the galaxy. The timeline for interstellar exploration is accelerating rapidly due to quantum technological advances. What seemed like distant future possibilities are now being actively developed and tested. The first quantum-enhanced interstellar missions could launch within the next 2 decades. Investment opportunities in quantum space technology are enormous and growing rapidly. Companies developing quantum propulsion, navigation, and communication systems for space applications are attracting billions in investment from both government agencies and private investors. For humanity, the quantum revolution in space exploration means that we are on the verge of becoming a truly spacefaring civilization. The combination of quantum propulsion, navigation, communication, and sensing technologies is removing the barriers that have confined us to Earth and opening the entire universe to human exploration. The quantum space revolution represents more than just better technology. It's the foundation for humanity's expansion into the cosmos. We're developing the tools needed to explore other worlds, find life beyond Earth, and ensure the long-term survival of human civilization by becoming a multi-planetary species. Thank you for joining us on Click Future, where your future is a click away. Next week, we'll explore how quantum computers are revolutionizing manufacturing and materials science, creating products and materials that were previously impossible to produce. The quantum revolution is transforming how we make everything from computer chips to spacecraft. What are your thoughts on quantum space exploration? Are you excited about the potential for interstellar travel? Let me know in the comments below, and don't forget to subscribe for more insights into the quantum technologies that are expanding the boundaries of human civilization.